Last time we explained how hash functions work. We saw what we can expect from a cryptographically secure function that returns an output of 256-bit length. In this video we will discuss asymmetric encryption, private keys and public keys. A good analogy for that would be a cookie jar. Imagine you have a cookie jar. The cookie jar has a lock and two keys. One key opens the lock and the other one locks it. Let's say one day you made copies of all of these keys and distributed them to all your friends. Now, from the point of view of cryptography, you have two things you can do. The first thing you can do is keep to yourself the key to open the cookie jar and give to everyone else a key to lock the cookie jar. In this way, everyone can put things inside the jar and lock it, but only you can open it. This is called asymmetric encryption. If you think of a cookie jar as a file, that means everyone can write a file, encrypt it, and send it to you, while only you can read it. So that was the first option. The second option is that you keep to yourself the key to lock the cookie jar and give everyone else a key to open the cookie jar. This means everyone can open the cookie jar and see what's inside, but only you can put things in the jar and lock it. Therefore, if one of your friends opened the jar and found something inside, you must have been the one who put it there. This way is called a cryptographic signature. Why? Think again of the jar as a file. What does this option mean? Only you can encrypt the file, and anyone you send it to can open it. That means that if they were successful at using their key to open the file and read it, it must have come from you, since you are the only one with the key that encrypts the file. Usually in Bitcoin and blockchain, we speak about cryptographic signatures. So a private key is the key that only I know, and that can be used to encrypt, or sometimes as it is called, to sign the file. A public key is the key that everyone else knows and is used to verify the identity of the person who signed the key. Pairs of public and private keys are generated together, and one public key can only verify one specific private key, and vice versa. The public key is sent or is placed somewhere that is accessible to everyone, and the private key stays secret on your computer or written somewhere else safe. When we'll talk about MetaMask, we'll see some cool ways to keep your private key safe. Private and public key pairs are used with Bitcoin wallets, Ethereum accounts, and almost all other blockchain-based systems, such as Hyperledger and Corda. That's it for the second part of cryptography fundamentals. In the next lesson, we'll see how private and public keys are used to interact with contracts and browse different parts of the Ethereum networks. Thanks for watching, and we'll see you next time.